In this video, we'll begin our discussion of trigonometry. We'll start with this whole section will mainly be definitions. With this whole course, I am going to create a bunch of small videos so you don't have to sit and watch me talk for an hour and a half for a lesson at most. But hopefully these small chunks of videos will help you reference back to videos after you watch them and be able to get the information you need for homework. So for every beginning lesson of a unit, I will post, or section, I will post learning outcomes on the top. You guys can take a read to that. That'll tell you everything you're needing. This is also what everything is called. That way, if you're seeking help with a tutor, or if you're Googling, or whatever you need to do for help, or if you're bringing it to me like, hey, I really need help with this, these outcomes will help you know those definitions and terminology so you can communicate to me or a tutor or another professor or a peer. Okay. So we will begin with a bunch of definitions. I left blanks here to kind of keep it interactive. I will try to do that throughout. I also leave all my examples blank on the handout. Please find the handout on the website. You can print it. You can put it on a tablet if you have one of those. But my recommendation is not to sit here and just watch the video, but to do some kind of writing to get your brain engaged. I know that watching videos can be very difficult. I've had to put myself in that world as well. Most of my meetings now are on Zoom. It is very difficult to be behind a screen all the time. Give yourself breaks and try to be interactive as much as you can, like you're in class. Okay, so starting off, we're going to define an angle to begin with. To define an angle, we have to start talking about the things that actually make up the angle. So to begin, we have what is called a directed line segment, but in high school geometry, they called it a ray. It's still called that. This thing right here to the left actually has a lot of names. Right now, we're going to call it a ray. Towards the end of the semester, we'll call it what's called a vector. Those of you that are STEM majors and you're going to go forward and you're going to see me later through calculus. In Calc 3, we start talking about three-dimensional calculus, and this directed line segment or ray, or what is called a vector, is extremely important. Okay, it consists of one point called the endpoint. That's right here. Right, so there's my endpoint, and then it goes to another point F, and it just extends one direction through that point. It takes 2 points to define an array, just like a line. It is the same thing as a line, except for it only extends indefinitely one way. Okay, the first point is called the endpoint. Right, so there's endpoint. Let me make this a little bigger. The smaller it is, my handwriting looks worse. All right, so we use two rays to define an angle. We start with, if we'll take a look at this picture here, we have this ray going EF here, ray EF, and then we also have ray ED. Those two different rays can define an angle. So an angle is the union of two rays having a common endpoint. The endpoint is called the vertex. So the angle we're actually talking about is starting on one side and going to the other like that. These have names. We're going to define them here in a moment. We usually name angles. We have different names for them, and this is typically what is used. We have theta. I'm going to write it in my handwriting too, so you can see what it's going to look like when I write it. There's theta. For phi, I just do a circle with a line through it. Alpha is like that. Beta, I just do a long stem. And then gamma, I don't really use because my gammas look like y's, but I typically do something like that if I have to use it. But I will be overly communicative about gamma if I decide to use it. Your textbook will probably use it, or the online program will use it. We can use any of these symbols for angles. We could use capital, which we will later in the semester, use capital letters to define them, capital B, capital C, stuff like that. But really, we could call them whatever we wanted. This is just the typical notation in trigonometry. All right, so here's some more of what that angle looks like. We're going to talk about another definition here for an angle. So there's my angle. This is typically what we write to show that. Sometimes we'll show the direction with an arrow. And then what we do to help us out, let's fill in the space at the bottom here, and then we'll talk about this last picture. So the measure of an angle is the amount of rotation from the initial side. So look at the picture right there in the middle. That's the starting side is where we start, to the terminal side. And that's where it ends, terminal meaning end. Probably the most familiar unit of angle measurement is the degree. What the degree comes from is it's not something that I guess we discovered in some way, but civilizations before us, right? that have been working in mathematics, some of your older societies that worked with mathematics, decided they wanted to split the circle, right, the full revolution up into 360 parts. The big reason for this is 360 has a lot of factors. You can split 360 by 2, 3, 4, 5, 6. And you there's a lot. So I think the original people wanted coming up with degrees, wanted the circle to be broken up into 6 ways. That's really what they were desiring. So 1 degree is 1/360th of a circular rotation. Now, just keep in mind that this was arbitrary to the people that were discovering this and putting this all together. The 360, it probably stemmed from 360 days in a year. A lot of that was based on that. So a complete circular rotation contains 360 degrees. An angle measured in degrees should always include the unit degrees after the number, or include the degree symbol. This is going to be very important coming up when I define an angle in a different way. So anytime I want degrees, like if I want 50 degrees, I have to write either the word or I need to put that symbol. If you do not put that symbol there, it's going to mean something completely different and be way off. So degrees has to have the symbol or the word. Right? An angle, and this is where I was promising that third picture at the top there. An angle is in what we call standard position. And we're going to work with this a whole lot in the next coming videos. Standard position is when we put our initial side on the x-axis, started at the endpoint at the origin, and then the terminal side moves from there. This is going to allow us to talk about rotations, and we're going to break these into what are triangles. That's trigonometry is triangles. And I'll show you how to get there. But everything we do with these angles, unless we're creating some real world application, we typically put everything in standard position. It's just the easiest way to work with an angle, and you'll see as we go a little further why we really care about that. All right, if an angle is measured, so a couple things, I'm going to show a video here in a minute showing what an angle looks like when we move it in standard position. If the angle is measured in a counterclockwise direction, so counterclockwise here, it is a positive angle. So the angle is said to be positive if it goes counterclockwise, just like the angle up here in the standard position, how it's moving counterclockwise and not this way, clockwise. This angle is said to be positive. If it goes the other way, right, if it goes clockwise, then we know that angle is negative. So if it's counter, it's a positive angle. If it's negative, if it's clockwise, then it's a negative. All right, one definition here, and I actually really didn't see this definition until we started using a couple books as of recently, but I don't remember this from high school geometry. I've taught high school trig in my past. I've taught trig out of other books as well, and this definition really wasn't there, but we're going to use it. I'm going to use this word, so we need to know what it means. A quadrantal angle is that if its terminal side lies on an axis. So what that means, like a zero angle, that's kind of silly, but a zero angle here starts there and ends there. I can't draw a straight line to save my life, but my iPad will. So it starts and ends there. That's a zero angle. It's called a quadrantal angle because it lands on the x-axis. The next axis it could land on is it starts here and it goes straight up. Right? That's a 90-degree angle. Notice the terminal side landed on the y-axis. Okay, our next one, 180 degrees. Right? Starting here and landing on the terminal side. It lands on the x-axis, so it is quadrantal. And then our last one, and it's a good time to memorize these degrees while we're working at this level. 90 degrees is straight up. I think most of the people can do the 90, the 180. It's this 270 that people forget. I grew up skateboarding, so this 270 makes perfect sense to me. So if you did any kind of sport or anything like that required revolutions, you may be good. So 270 lands on the negative y-axis like that, all the way around. Okay, so those are quadrantal angles. I'm going to show you a video of an angle in standard position and the way it looks like it revolves, and we'll end the video with this. So let me move over to I just recorded a video of it. But as you can tell, this is our angle moving from 0 to 360. You can see how it moves through. We have any angle that we would want from this. We get 0 to 360. And if I wanted past the 360, I would just keep spinning, right? So if I wanted past that 360, I would just go, okay, around and we could go as far as I wanted. I could do 19 revolutions, I could do 100 revolutions, and my degree of that angle would get bigger and bigger and bigger. We could also spin the other way and get a negative angle. So angles are pretty easy to work with. We're going to define them in a couple different ways, but this angle idea is like most of trigonometry. Trigonometry is completely based on this revolution idea that's going to create triangles. So understanding these angles and how they spin in standard position is going to help you guys break down these three-dimensional ideas eventually. We won't get to three dimensions this semester because we have to understand it in two. But this is going to, the angle thing, the trig thing is going to open up physics for you. Those of you that are not going to do a STEM and not going to be a STEM major and you just have to take trig and they're just wanting you that, we're going to work on your critical thinking. You're going to have to get through the same stuff. But I do believe trig is this like new math, not new math, but finally outside of the algebra realm where we actually get to start doing fun things. And fun is subjective, but you know what? It just becomes a little more interesting than algebra. So I'll end my video here. Please watch the next one.